Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. This is Dr. Ahmad Al Faris. Today we are going to talk briefly about vertical motion with air resistance or without air resistance that be affected by gravity acceleration, and the acceleration remains constant or changes according to the other forces and the resultant force act on it. Let me introduce myself first. This is Dr. Ahmad Al Faris. I am physics and math M1 teacher for the last 20 years in Cambridge and edX and O-level, A-level boards. And I have PhD in education and curriculum of teaching methods of physics. Today we are going to talk about vertical motion freely. Now, before we started, let's say that we have an object here in the air, and this object, as all objects, it has affected by only one force acts down, which is the weight. That causes it to fall down, and as we know that this falling is falling with acceleration, and we know that the weight equal mg, so there is only one force acts on it, so the resultant force is equal to the weight, which is mg, and we know that the resultant force is ma. M with m cancel out each other, so the acceleration is g, the gravity acceleration. Now the gravity acceleration changes according to the position. The gravitational field strength on Earth is different than on the moon or on Mars or other planets. So what do we have to say? We have to say that all objects, okay, each object by itself, okay, all objects falls on Earth by the same uniform acceleration called gravity acceleration. Gravity acceleration. And this gravity acceleration, it happens for this object because there's only one force acts on it. Because there is a single force acts on it, which is the weight, Okay. So the weight here makes all this object falls with the gravity acceleration, and this gravity acceleration on Earth is equal to g and equal to 10 meters per second square. So what that tells us? That tells us when you drop an object, when we say drop, that means falls freely, okay, from rest. That means initial speed is 0. So the initial speed here, it will be 0. In the moment that I release it, the acceleration is 10 and remains 10. 10 after 1 second, 10 after 2 seconds, it's also 10, 3 seconds, it's also 10, 4 seconds, 10, and it remains constant, which is the value of the gravity acceleration on the Earth, okay, 10 meters per second. But for the object that, what the meaning? 10 meters per second, that means the speed increases every second by 10. So if it starts from rest, okay, that means after first second it will be 10, after 2 seconds it will be 20, after 3 seconds it will be 30, 40, 50, etc. So every second the speed increases by 10. How do we know that? We know that from the acceleration equal v minus u over 2. So if I make the v is as a subject of the formula and u is 0, so a times t, by doing cross multiplication, acceleration times time is the velocity. The acceleration is 10 times 4, for example, it will be 40, etc. The same thing happens for what? For the distance. Initially, there is no distance is traveled. After the first second, it will be 5 meters. After 2 seconds, it will be 20. Then it will be 45. Then it will be 80. Then it will be 125, etc. How do we know that? By the formula, distance equal u plus v over 2 multiplied by what? Multiplied by t. Now, this formula tells us that the initial speed is 0 after plus v, let's say after 3 seconds, the velocity is 30 and the time is 3. So 0 plus 30 is 30, divided by 2, it's 15, multiplied by 3, the times 3, which is, it will be 45. And that's the distance traveled, okay, if there is no other forces, if the resultant force is equal to only the weights. Okay, so if we say that the resultant force does not equal the weight. That means there is other forces. What is the other force? As the object is falling, sometimes like parachutists or big objects, okay, as they fall down, there is weight. There is a small air resistance that slows it down or resists the motion. So making the resultant force less than what the weight. It will be less. Eventually, as the speed increases, the air resistance increases, making the air resistance increases and equal and cancel the weight, making no resultant force and no acceleration to fall with terminal velocity. So, but if the object is affected by air resistance, that means if the object has some certain description, like if the object has, let's say, big volume, or let's say large surface area, or let's say, or low density, that's the most important thing, low density, it will be, it will be affected by what? By air resistance, by air resistance. And what actually air resistance do? Some say that they say that it reduces the speed. No, it does not reduce the speed. It decreases the acceleration. Why it decreases the acceleration? Because there's other speed, other force in the opposite direction. Decreases the acceleration. It will not be 10 anymore. It will be less. Why is this? Because decreases the acceleration since air resistance increases as the speed increases, making the resultant force decreases and also what? The acceleration decreases. Until what? Until the air resistance is equal and cancels the weight, making no resultant force. The resultant force is equal to 0 and the acceleration equal also to 0. And that's called something, does it stop in the middle of the air? No, it keep moving at steady speed forward, downwards, which is called terminal velocity. So let's return back again. Any object does not have low density or didn't mention about air resistance, that means the acceleration it's G 9.81. But if there is object affected by air resistance, the acceleration it will be less than G. Okay, and maybe eventually the acceleration will be 0 and falls with terminal velocity. So again, yeah, Shabab, we have to be careful. If the object has no air resistance, it will fall with acceleration very fast, 10 meters per second square. But if the object has a large surface area or parachute, it will slows down like this and eventually reach safe. Okay, so we can use the air resistance according to the question. Let's say this question, we have a small steel ball, like small that affected low by air resistance. A steel, that means it has large density, there's no air resistance, dropped from a low balcony, that means doesn't reach a high speed, be affected by air resistance. And also dimension, ignoring air resistance, which statement describe the motion. It will move with what? Uniform or constant acceleration. It will not move with constant speed unless there is air resistance cancels and balance the weight. It will not move with decreasing acceleration unless there is air resistance and the air resistance increases, making the resultant force decreases. It will not move with decreasing speed, never, unless we've opened the parachute or we're talking about not vertical motion, not dropping. Okay, next question. What they said, I'm talking about dropping. I think that we drop it, okay, the acceleration from low distance, it's approximately 10, which is the gravity acceleration. 3 balls are dropped from a bench. Which ball have the same acceleration? 3 of them, they have the same acceleration because they are talking about a bench, not the very high height. Okay, they are having the same acceleration, the acceleration of gravity at 10 meters per second square. Now we have 2 men here, jumps in from an airplane at the same time. One man opens the parachute, as you can see, large surface area, and one does not. Okay, so why the man in the free fall moving faster than the parachutist? Because the parachutist experiencing a greater air resistance. So this is the answer. Let's look at the answer. The man in the free fall experience a greater air resistance. That's not correct because it doesn't have large surface area. The man in the free fall has a greater mass. That doesn't matter and does not affect the motion. Okay, part D. Okay, the parachutist has not reached the terminal velocity. Even if it does not reach the terminal velocity, that doesn't mean that the free fall will not move faster than it. Okay, we have to know that the power of the air, we can use it. Alhamdulillah, Allah اختارنا إياها. تمام. Any question? If you have any question, you can send it to me, Dr. Ahmad Al Faris. This is my number. You can send it to me on the WhatsApp. Okay, let's prepare yourself يا شباب. جيب لنا قلم وورقة. Okay, pencil and notebook, and let's do some questions. What they say, this past paper question. The figure here shows a powerful hose that water can get out from here at very high speed, and it slows down, slows down, slows down, slows down, and eventually it stops at the maximum height. Then speed up, speed up, speed up, speed up, and what return back to the ground. They saw that here that the one water drop, they neglect the air resistance. That's why it's straight lines, and that's not correct. Okay, so it's leave from 40 meters per second, and it's move upwards with decreasing speed uniformly. Okay, then it's moved down with what, with increasing speed, okay, as it reached the maximum height here. Okay, it does not, that this line does not goes down, that means it's going down. No, it's the speed is decreasing as it moves up, and the speed is increasing as it falls down. Okay, describe the motion in the first 4 seconds. Uniform deceleration upwards until it stops. Uniform deceleration upwards until it stops or reaches the maximum height and stops. Okay. The next part B, that was part A, use the figure above to find. Now we have to use the figure. Now what do we mean by using the figure? We will use these numbers here, these numbers here, and maybe these are the answers. We are going to find the gradient or the area under the graph. These, how we can use the graph in any question. Use the figure above to find the speed of the air leaving the hose. The speed leaving the hose, initially it was 40 meters per second. Okay, at the time when the speed reaches the least speed, what was the least speed at 0 meter per second? It was at 4 meters, that when it reached the maximum height. So we write 4.0 second, two significant figure. That's why I write 0.0. Use the values from the graph to calculate, not to estimate. Use the graph to calculate, okay, the acceleration. Now we know that the acceleration is equal to the gradient, or you can say it's v minus u over t. So in both situations, we're going to talk about the gradient here as it falls down. Okay, so the final speed v, which is 40, and that's happened at 8 seconds, and the initial speed of falling, it's 0 at 4 seconds. So it will be 40 minus 0 divided by 8 minus 4, and the answer is 10 meters per second square. Why it's 10? Look to me, attention ya shabab. Why it's 10? It's equal to g. It's the gravity acceleration. Most of the time they ask this question, the answer is 9, 9.5, 9.7, 9.8, 10. Okay, so you have to be careful. Calculate the greatest distance. Now, we know that the distance is equal to the area under the graph. So only we have two formulas here. We have that the acceleration equal the gradient, okay, and we know that the distance equal the area under the graph. So you have to be careful about this. So here we have to find the distance in the as it reached the maximum height. The maximum height reached here, so they ask about this distance, okay, this area under the graph in the first 4 seconds or the last 4 seconds, because the time to go forward is the upwards is the same time to go downwards. So this is the right angle triangle, which is half multiplied by 40 multiplied by 4, and the answer is 80 meters. Okay, تمام. If you didn't prepare yourself, يلا bring me a notebook and a pencil or pen. يلا اشتغل معنا. Next question, what do we have? A solid plastic. Plastic means affected by air resistance. Okay, false, that means start from 0. Okay, and affected highly by air resistance because it's plastic. Okay, towards the earth, the figure shows the speed time graph until it hits the earth. It hits the earth at this moment after 100 what second. Describe, not explain. Describe, only mention, talk about the motion, the speed, the acceleration, the stops, these things. Okay, describe the motion as do that. I will, as you can see, I will do that in 3 different sessions, from P to Q, from Q to R, then from R to S to T. So from P to Q, then from Q to R, then from R to S to T. I can do that as bullet points, or I can write it as paragraph. I prefer as paragraph, but bullet points to know that we have 3 marks, okay, and the 3 marks according to the 3 different points, okay, that we are going to talk about that. So first of all, from rest falls at uniform acceleration. As you can see, the speed increases, and it's a uniform because it was a straight line here in the beginning. So the speed increases. I will not say that increasing speed because this is acceleration. I will write uniform acceleration. Then the acceleration, what happens to it? As we know that the acceleration here decreases, because as the speed increases, air resistance increases, making a resultant force decreases, and also the acceleration. Then what happened to the acceleration? The acceleration decreases until what? Until it reaches terminal velocity, until the speed is constant and reaches terminal velocity. You can say terminal velocity or constant speed, you will get the last mark. And that's how we are going to answer this question. Okay, these are the 3 marks for part A. Okay, again, why do that? Because initially the speed was slow, so that means there is no air resistance, so or the air resistance is negligible. After the speed increases, the air resistance becomes appreciable. صار في air resistance, the air resistance effective. As the speed increases, air resistance increases. Resultant force from the weight down and the air resistance up, making the resultant force decreases, and it falls with decreasing acceleration. Eventually, at a high speed, the air resistance is equal to the weight, and they cancel out each other, so making no resultant force, no acceleration. That's why the line is horizontal here. That means it reaches the maximum speed, which is the terminal velocity. Okay, next part B. On the figure, draw arrows to the direction where the forces act on it and label these forces at the point S. Now, I will not answer this question. I will answer 3 questions here. I will answer, okay, at 3 different times here. I will answer at t equal 2 seconds in the beginning, at t equal 20 seconds after a while, okay, and at s. I will answer this question 3 times. So let's say at t equal 2 seconds, somewhere here, okay, it was in a straight line. At t equal 20 seconds, somewhere here, okay, it's curved line, and at the point is that they ask about it. So what's happening here? We know that every time there's an object in the air, or still, or in motion, or doesn't matter, okay, there's weight acts on it, and this weight acts, I'm sorry, vertically downwards, and this weight does not change because the mass doesn't change. So the arrow, the length of this weight doesn't change because the weight remains constant unless the object loses some of its mass, like one of the questions that they bring it a couple of years ago about rockets. Okay, so the weight remains the same and does not change, and this is the always force act on the object when the object is close to the planet like Earth. After a while, in the beginning here, there is no air resistance. Okay, it's negligible, but after a small speed, the speed becomes small. There is air resistance, and this air resistance, it was small, and that's why the acceleration decreases less than 10. But at point S, the air resistance is equal, the same length of the arrow, and the air resistance is equal, and cancel what? Cancels the weight. Okay, that's we didn't answer only 2 mark question, we answer 5 marks question. Okay, next part C and D, we have to explain what's happening, then we have to calculate approximately the distances. Now here we do have explain why the sphere is moving with a constant speed at S. It moves at a constant speed with S because the air resistance is equal and cancel the weight. The air resistance cancels the weight. So as it cancels the weight, what that happens? Cancels the weight, making no resultant force and no acceleration. So there's no acceleration, that's why there's 2 marks. No resultant force, no acceleration, we get the 2 marks. Cancels the weight, making no resultant force, no resultant force, and no acceleration. And that's how we answer this question to get the 2 marks. Then use the graph to calculate the approximate distance. Now we know that the distance equal area under the graph. Look here, they ask about the distance from R to S, from R to T, sorry, to T, from here to here. As you can see, it's constant speed, so the area under the graph, or speed times time, can we use this to find the answer. So the area, okay, of this shape of the triangle, and it's equal length times width, and the length is 120, okay, multiplied by the width, which is the time, which is 100 minus 60, which is 40, okay, and the answer is 4,800 meters. Okay, the distance between P and Q. If they ask about the distance between P and Q, okay, that means we are talking about a small triangle here, and we have to find the area under the graph here. As you can see, the base here, it's 2, 4, 6, 8, 10. Okay, and the height here, it's in the middle exactly between 40 and 60, so it's 50. So the distance whole is also here, also equal the area under the graph for this small triangle, which is half multiplied by the base, 6 multiplied by the height, which is 50, and the answer is 150 meters. Okay, sometimes they ask a smart question, and they ask about the distance of falling. How they ask about the distance of falling? Sometimes they say that find out the whole distance, estimated. So if I want to estimate it, that means I will find also the area of this trapezium, okay, and add it up with this area, and with the small triangle, and I will estimate approximately how much is this area. For example, if this area it's 150, that means this area it will be approximately 300, 400, 500. That's why there is range of the accepted answer. Whenever you are accurate, you'll be getting the 3 marks of this finding the whole area. But be careful, ya shabab, we don't have enough time to be accurate to get the exact mark. We have to run in paper 4 as fast as possible to answer the whole question. That's why we are estimating as fast as we can the whole answer. Okay, يعطيكم العافية. If you have any question, you can send it to me again on my WhatsApp. تمام. Let's do this question, the last question. What they ask in the beginning, they ask a question: which of these quantities are vector quantities? The vectors quantities are the quantities that they have direction. This doesn't have direction, energy doesn't have mass and volume. Only the force and the velocity, they have direction. Now, a small metal ball projected into the air with a speed of 40 meters per second vertically upwards. This is speed vertically upwards. As you can see, it's slowing down because it's moving upwards and the gravity acceleration is downwards. Okay, this is the velocity time graph as it changed, okay, until it reached the maximum height somewhere here. Shabab, ركز معي بلاش اخبطك. يلا ركز. What the question asking? Find the diagram, use it to find out. We have 3 sections here: I, double I, 3, triple I. Okay, what they ask: the time to reach the maximum height. Look here, it's not 4, it's 4.1 or 4.08, so 4.1 second. The deceleration, we say that several times, as the acceleration and the deceleration is the same thing. It's finding the gradient, okay, and finding the gradient, that means rise over run. So 40 minus 0 divided by 4.1 minus 0, which is forget the negative because they ask about the deceleration, which is negative already. So forget the negative sign, which is 9.76, or you can write 9.8, 2 significant figures, meters per second watt square. Okay, don't fall easily, okay, because this question is easy. No, you have to control, you have to be focused. Okay, tamam. Last part, triple I, calculate the maximum height reached. They ask about the whole area here. How much is the area under the graph? شايفين دائما عم بنعيد نفس الأسئلة، عم نحكي نفس المواضيع. Area under the graph for this triangle, it's half times base, 4.1 times height, 40, and the answer is 84 meters. Okay, or 82, I'm sorry, 82 meters. That's what the maximum height. Now on the figure, okay, that's a good idea question. On the figure, add a line to the graph to show the velocity after it reached the maximum height. What happened to the object? It keeps falling, but where? Downwards. Okay, negative, not going up like this. That's not correct. It's keep falling what? Downwards. And how does it fall? With the same uniform acceleration. So what I will do here, I will continue this line by my ruler, okay, like this, a straight line by my ruler until it reaches the 6 meters. That's how we answer this question, and that's how we get the smart idea. If you have any question, you can send it to me. Allah يعطيكم العافية. We did a perfect work now. Allah يعطيكم العافية. Okay, that's it for now. Okay, all the best. I wish all the best for you and make me proud. يعطيكم العافية. السلام عليكم ورحمة الله وبركاته.